Hello everyone. Today we're going to look at trying to work around one of FreeCAD's worst enemies, which is called the topological naming problem. You may have read about this when you were trying to understand why your models were breaking, and some people in forums say, "Oh yeah, it's the topological naming problem. Don't worry about it. It's a known problem. This is how you solve it." And I want to show you how to create your models so they are robust. First of all, I'm going to show you two example parts. One that I generated so that it absolutely breaks the moment you touch it, and one that doesn't. I took inspiration from a popular exam for a solid modeler that I'm not sure I can use in my videos, so I just won't. But the part is inspired from one of these exams. And I'll show you the part that breaks first, and that's what the part looks like. It's a hinge-looking part. I have skipped some features to bolt it down, but basically it has a couple of ribs, and I've made it so that it's absolutely terrible from a modeling perspective. No, I'll try and remodel it for you, but first of all, I just show you what happens if I try to modify the rear rib by simply adding a rectangular cutout. I'm not changing anything, just adding a cutout. I'll leave it unconstrained, leave the sketch, and everything absolutely breaks. The cutout is here. If you roll back to the feature, but it just breaks everything if you try to continue in the tree. And I'll do the same in the part that doesn't break. This is what the part looks like. If I go to the rib sketch and just add a cutout like I just did, you see that the cutout will propagate and nothing will break. So how to do it in practice? Let's start from the beginning. Let's try and break apart and figure out why. So I have a new part. I'm going to create a new body. I'm going to show the origin by pressing space, and I'm going to start by drawing the main cylinder. So I'm going to sketch on this plane. I'm going to draw the circle with a hole, and I'm going to add a couple of dimensions to constrain it. I'm going to call this 50 millimeters. I'm going to call this 30 millimeters, and I'm going to extrude it in one direction by 100 millimeters. Next up is creating the rear sketch for the rear rib. So I'm selecting this plane, creating a sketch on it. I want to get the geometry, so I'm going to use the external geometry tool. I'm going to use this, and then I'm going to create a polyline from the cylinder up to here, and I'm going to create an arc. I intentionally do things so that it's obvious if I manage to constrain them well. So I want to make this horizontal first, and then some symmetry constraints. So symmetry of these corner points, symmetry of these corner points, and then all I'm left to is to dimension the height and width of this part. So I'm going to dimension this distance first as 50 millimeter. And I'm going to dimension the length of this, and we should be, so I'm going to constrain the distance between the center and this point to negative 50 millimeter. We are fully constrained now. I can come out. I'm going to extrude the sketch that I just created by 15 millimeters along Y. So to do things properly now, you should start thinking about, so to do this properly from now, you should really start thinking about datum planes, but we're going to do it badly on purpose. So I'm going to use this face to create a new sketch. And from this face, I'm going to first activate the cutout, and I'm going to use as a reference an edge. So this rear edge, and I'm going to create a rectangle out of it because I want to create a rectangular base. So using this as reference, I'm going to leave this unconstrained on purpose and constrain it afterwards. And then we're left to size the length of this, and I'll set this to 90 millimeters. That's all done. Can come out and extrude it towards the bottom by 8 millimeters. And then all I'm left to do is create a rib that extends from here outwards. And again, because I want to do things badly intentionally, I'm going to use this plane as a reference. I'm going to sketch, and I'm going to create a projection of this arc and this bottom part. I'm going to create a rectangle again, and I'm going to make sure that I have an arc that is properly inserted as geometry. I'm going to remove this, and then I'm going to try and finish constraining everything that hasn't constrained itself automatically. A little bit of symmetry. So I'm going to set this distance to 7.5 millimeters, and then inevitably I haven't constrained something, which I don't know what is happening exactly, but I'll try and constrain this to the line instead. There we go. It's done. I have a sketch, and then I'm going to extrude the sketch up to the face of the cylinder, or of the face of the base. Let's use the face of the base. That makes sense, doesn't it? Yeah, let's try this. The tree looks acceptable. So we started from a cylinder, we built a cylinder off the back of it, we built a bottom part of the bottom face of this rib, and then we created a rib off the back of this feature. So now, of course, your client will be like, wow, do you know, I really like if this had some circular cutouts on the back. And you go back in your model, you go to your sketch that defines the feature, and you're going to create a couple of cutouts. You're going to do something that looks like this. You don't know the size yet, but you're just going to try it. So that works. You have two circles. We have some red already. And the bottom has, interestingly, come up with a shape that we didn't really define. And of course, the pad has failed. You can see it's failed. It doesn't look like it's failed, but this is the last state that worked. Unfortunately, sketch tree is now defined by some references that don't exist anymore. What happened to this? Well, what happened to this was some line that we projected changed its name because FreeCAD is optimizing the the names of all these lines in the previous sketch. Of course, this is not an exhaustive explanation of the topological naming problem, but what happens under the hood is things change name, so you're not referencing the same object on the child sketch, and the result is chaos. If you look at my GitHub, I managed to do even worse. So let's go back to the part that we managed to break. How do we unbreak it? Well, I could just delete these, tell our client that the cutouts they wanted aren't really possible, and ship this. But if you're interested in modeling parts like a professional, where you can actually go back, change something, and not have the model completely explode on you, then stay tuned, because I'm going to explain how. And we're back. I've created a new FreeCAD document. I'm still in part design. I'm going to create a new body. In the body this time, instead of creating solid things straight away, I'm going to create a skeleton of sketches. I'm also going to start using renaming things in the tree, because it's good practice, especially if you want to explain to a colleague or even to yourself in the future what a certain feature is. So first of all, create a sketch in XZ in this case, and I'm going to also name some variables so that I can see them in the model. So best practice is to name your variables. So this, I might call it OD as outer diameter. This I will call ID inner diameter. And the beauty of doing a proper parametric model is that you should be able to just put random numbers now and change them later when you know the real dimension that you need. This is going to be cylinder sketch. I tend to use underscore sketch for sketches, and then you can press F2 to quickly rename things. And then I'm going to dimension this to 100 millimeters. This is going to be cylinder pad. I like to keep the name of the feature in the name. What I'm going to do is I'm going to hide cylinder pad and show cylinder sketch. So I don't want you to go and just do bodies from here. What I want to do is I want to define a few datums. I want to define where the bottom is, maybe also where the top of the bottom plane is, and a couple of other features. So one thing that I like when I do extrusions is I like to end extrusions on a datum. So to do that, I'm going to offset from this plane along this axis. FreeCAD works in local coordinates, so we are going to have to use the local Z direction. As you see, I put 100 millimeters and the plane offsets parallel to itself upwards if you are the plane, and in our case is along Y. This plane is cylinder face. I can now edit the pad to refer to cylinder face instead of having the hard-coded 100 millimeters. I can't do it because cylinder face is in the future with respect to cylinder pad, but I can move object after other object. I can move it to the beginning of the body, and they have now swapped places. Now I can edit the pad, and I can set this up to face to this axis. So all the geometry is going to be defined either in sketches or in datums. So turn this on, turn this off by pressing space. I want to create the bottom of the base, and I'm going to create a datum plane. Again, we're going to use negative Z minus 60. Maybe I'm inconsistent with the previous example, but it doesn't really matter because we can go and change it anytime. And I'm going to call this bottom plate. What I want to do is I want to define the plate thickness, but I want to be able to refer to it later when I create the ribs. So I want to offset from the plane I just created in positive Z, and I want the plate to be 8 millimeter thick. And this is going to be plate thickness. So now I think I'm ready to draw the rib off the back. And to draw it, again, I'm going to use a sketch on this datum plane. Remember, when you have planes shadowing something, you can't really select this geometry until you click on view section. Once you click on view section, you can select it when trying to project geometry. So I'm going to project the outer radius diameter of the cylinder and the plane. And you can see the line is infinite. It's not just a line with 2 points. And this is really useful because the line with 2 points is, if you break it, it can move around, whereas a plane is just going to be a plane. I'm going to do this, and I think I've missed the constraint, yeah, but I can fix it real quick. I can constrain this to here, and then this is symmetric. I can add the arc. Again, I'm going to add the arc comically this away from the constraints so that I'm sure I can pick the constraints up later. Once that's sorted, I can fix the horizontal size to 8 millimeters. I forgot to set it symmetric, or it lost the symmetry at some point, but I'm going to redefine it. There we go. That's fully constrained. We can leave the sketch and leave the sketch there, because for now we don't need to do much just yet. I want to then define the other part of the rib. So again, on the same plane, I'm going to create the triangular shaped rib. And this is the one that we'll try to modify later. So I need to import this geometry and the plane again. And I need to create a polyline in the hope that this has constrained itself to the cylinder. I'm going to set it symmetric, and I'm going to try and break it after I've set these symmetric as well. So once the bottom is also symmetric, we can try and set it. So set the height, the vertical height between these two. Let's do it consistently to the other model. Set the distance between the horizontal axis and also set the width to a number like 70 millimeters. I'm still missing the arc, which I'm going to draw now. And all we need now is the bottom plane. So one thing I want to be careful now, so I want to draw the footprint on maybe the bottom plane because it's the first one. I want to rename these sketches as well. So longitudinal rib and rear rib. I want to be a bit careful. So if I create a sketch here and then hide this, you would be tempted to reference the line here, which gives you the width. You can do that. In this case, we're going to try and see what happens and see if we break the model or not when we add an extra cutout. So let's try and project this. And then from here, I'm going to draw a rectangle. And it should be just constrained to these points. And the only dimension I need to fix is the width, is the length. Again, you can set this up in an external plane. In this case, I'm just going to set it here because it's not functional. So I think we have everything. I'm just going to rename this base footprint, and then we can carry on and re-enable the cylinder. We don't need the sketch to see the sketch anymore. We're going to You'd be tempted to try and extrude the bottom plate first. You can't do it because in part design you can't have disconnected bodies. So we have to do the rear rib first. So I'm selecting rear rib. I did say that I was going to call these sketch. I'm going to rename all of these to underscore sketch. And then I'm going to create the rear rib first as a pad. And again, I said 15. This is rear rib. What this has done, it has moved the sketch to the bottom of the history. So you'd think the base footprint sketch shouldn't be able to reference that. But this is a quirk of the way FreeCAD handles this. So this actually exists before in the tree. I don't particularly like this, but as long as you're consistent, you shouldn't have a problem with this, because now as soon as we create a pad, and I'm going to have the pad end at the plate thickness, so up to face, this plane, I'll call this pad base footprint base. The last thing we need to do is we need to create this long rib. Now we could end the long rib on this face and see what happens. I'm going to go up to face and select this face. Okay, so again, client comes around, says, "Ooh, that rear rib, I want a gaping hole in it." I'm going to create a gaping hole in it. That maybe also intersects the rib. And this has terribly failed. Why did it fail? So if we look at the rear rib sketch, this is under constraint, which is fine. But if we look at the base footprint, that is also fine, because it's still referencing the right parts. What's failed is the long rib. So the problem was that what was face 16 has now become face 15. So I'm going to cancel this and I'm going to fix this model, because I did this a bit better. So I'm going to create a plane. So I'm going to go back to kind of the before times, and I'm going to create a plane that shows where the bottom ends. So I'm going to create this so that the plane is 80 millimeters off Z, and I'm going to call this base plate front, and I'm going to move this to just after maybe plate thickness, so I have all the planes together. What I want to do now is I want to roll back to base footprint sketch, and I want to make it so that this constraint is driven by the plane itself. So I want to project this plane on my sketch, and then I want to use it as a reference. So I'm back here, and I want to constrain this node to the plane. That's constrained. Close this, and now the base ends there. I'm going to delete the feature. I still have the sketch that I can see around the back here. And what I want to do is I want to set this to be the origin of a pad. The pad is going to go up to this face. That's done. So we have the gaping hole, we have the pad, and we are done. So if I hide some of the construction planes, and then we go in and maybe remove that from the rear rib, because again, the client has changed their mind again. The model hasn't broken. We can also change the dimensions from the constraints area without many things breaking. We can change the positions of the planes, so we can change the plate thickness to match the to a different number, and that works. The only thing you have to be slightly careful is if you look at the properties, you have attachment, base, and size. You won't be able to edit size. If you go into base, you won't be able to edit position. You have to go on attachment, position, and then here you'll see the dimension available. So we can set it to 1 millimeter or 20 millimeter and change it dynamically. So this model doesn't break. One thing we can try, you can go even further and modify the cylinder sketch to have a bunch of nondescript through holes. Again, not the best way to do this, but it's just to illustrate a point. If I come out of here, the holes are there, the model is perfectly intact. Okay, so just to recap, you want to break your model things off of other features. This is a surefire way to have a model that will not be stable and will break the moment you touch it and you touch a feature, especially if the feature is quite high. You don't want a part to break. Create as much of a skeleton part as you can before even touching the geometry. And especially with datum planes, if they are functionally meaningful, it's going to be really easy for you to later change a functional dimension. So for example, you might want to do variants where this is 100 and then you have a different part that is 200. So that allows you to do really quick changes. So anyway, I hope this helped. As always, you can find the parts for this and a text version of the tutorial on my GitHub. Link is in the description. If you have any questions, leave a comment. And yeah, feel free to join the channel if you like this content. Thanks very much. See you later.